Students, you are majorists, fellow learners. Today you are in luck because today I'm going to show you two things. The first is my presentation, which is very obvious. The second is, ladies and gentlemen, please welcome the beautiful lady from Japan and give applause please to the lady. Ladies and gentlemen, as you can see, she is wearing a traditional fabric. Now, thank you, you may sit down. Now, believe it or not, this is the problem of my research. Do you like fun facts? I like fun facts. Fact that in 2012 itself that there are more than 150 owners of home socket industry. You might think it's good, you might think it is a culture well preserved. But also a fact that they produce more than 5,000 of liters socket liquid waste every day for each color. Now, the thing is, the obvious effects can we see on the Musi River. Why? Because most of that socket liquid waste, they would be thrown away in the Musi River. But then again, me and my team found out a resource, which is rice straws. Now the thing is, about rice straw, first is, it is abundant. As we know that Indonesia has rice as its staple food. Second thing is, it is considered as trash by the locals. I have seen a lot of farmers that would just throw it away or burn it instead of using it. But they have the vital structures in order to absorb the dye. So the idea of my research is we can use that rice straws to absorb the dye instead of being thrown away unprocessed. So that's why this bare fabric is namely one of the biggest irony in Palembang. Anybody can guess who said that? Ladies and gentlemen, the one who said that was me. So, I have conducted an experiment namely rice straws as potential Musi savior. Now, how can the dye unprocessed be thrown away in the Musi River would be dangerous? Well, for one, let's just say that the box is the river. It has a lot of oxygen, and it is contaminated by the dye. Now, the penetration of sunlight will be blocked, and thus reducing the amount of oxygen in the river. Now, the second problem is the dye used when thrown away in the Musi River, they can be broken down into an amine aromatic compound which will be far more dangerous than the dye itself. And the effects can be brutally seen by the dead fishes. Now, if you're wondering on how this rice straws can actually absorb dye in the river, is that they have the vital structures with this cellulose, hemicellulose, and lignin and ash. Now, the rice straws also have the molecular sieve structure, which allows the rice straws to absorb dye. But the problem is, does the amount of rice straws used have an effect on the effectiveness of the absorption? Second is, what is the optimal amount of rice straws used to completely absorb the dye and thus no more contamination to the Musi River, or at least preventing furthermore contamination? Now, in order to prove that, I have conducted an experiment, which is firstly is preparing the rice straws by cutting it 1 centimeter each, cleaning it with water, then drying it again, and then weighing it for 15 grams, 20 grams, and 25 grams, which I will explain later on. And then there will be an activation process using a 15% sodium hydroxide. The process occurs for a full day, and then dry it out again, and then clean out, and then dry it out again. There are 9 samples, 3 different treatments, and 3 repetitions. The property of the dyed water used is 50 milligram per milliliter, or 5% concentration of dyed water, by using 150 milliliters of polyol. Now, like I said, there are three ways. The first group, which I call as Group A, was applicated with 15 grams of rice straws by just soaking it in, and then wait for one whole day. The second group, I would like to call as Group B, applicated with 20 grams of rice straws. Third group, applicated with 25 grams of rice straws. Now, the mechanism of how does the rice straws actually absorb dye is shown in the picture. That rice straws have cellulose structures and hemicellulose and many other things, and they have a hydroxide structure in the end. Now that hydroxide ion and chlorine will react and form a chloric acid, which makes chlorine will be replaced with cellulose, according to the right picture. And I don't have a pointer, so I can point it out. The second mechanism is by using hydrogen bond. As we learned in high school, hydrogen bond is the strongest bond of all among polar bond and non-polar bond. So the hydroxide ion, which has the hydrogen, can react with the nitrogen and tends to make a strong bond which exists in the dye. Initially, there was an experiment done, but there was a difference. The previous experiment uses approximately 5 until 7 grams of rice straws and using only 50 milliliters of dyed water. But it has also a different concentration, which is 5%, 10%, and 20%. They have the effectiveness of 80%. Now, the current experiment, this is the picture of the first experiment. Now, the current experiment has a very low experiment compared to the first one, which has approximately 30% of absorption effectiveness. Now, there are two theories. This is the picture of the absorbed dye. Actually, there are two theories on how does it differ. The first is the age. So, the rice straws used in the current experiment, as you can see, is still green looking. So that means it is not rice straws. Technically, they are not rice straws, but they are still rice in the growth process. But in the first experiment we used a rice straws after harvested. So the theory goes like this. The harvested rice straws, they have more cellulose and lower amount of water, and thus they have the maximum absorption capability. The second theory on how does the first experiment and the second experiment differs is, well, of course, it's not a theory actually, but the first experiment have 50 milliliters of water, of dyed water, so maybe the effects can obviously be seen by using 7 grams. So the conclusion, the rice straws in a relatively young age, they have the effectiveness of approximately 30% to absorb the dye. Now, in the current experiment, the amount of the rice straws can significantly increase the effectiveness of absorption. And the best result in this experiment was using 25 grams. In the future works, I would like to do an experiment to actually be certain on how is the optimal amount of rice straws used. And then I have to do an experiment on how does the age differs, and then actually cleaning the moisture. I have a quote that I really like. It's from Lao. It says, "A journey of 1,000 miles starts with a single step." I have never expected that this research would be the instantaneous solution for the Mississippi River. But then again, that is not a 1,000 miles journey. My research right here is just a single step of the future of Mississippi River. Thank you.